The most commonly asked question on the IB exam regarding the normal distribution is for you to find their proportion or probability of some event happening. And if they ask for that, you are almost certainly going to use the normal CDF function on the calculator. You can find that by, on your calculator, you hit the second and the vars button to bring up the distribution menu. And when you get to that place in the calculator, you'll see normal PDF, normal CDF, and INV norm. I didn't write this, I didn't actually type it out in the notes. You'll see the option there for normal PDF. Normal PDF is completely useless. Please don't ever use normal PDF for anything. The one you want is normal CDF. So yeah, seriously, don't ever use normal PDF. It has value somewhere else, but not for our purposes. So normal CDF is the thing you want. To compute the area, so if you guys, if you hit normal CDF on your calculator, to compute the area under the normal curve, you just have to enter the lower and the upper bounds, which basically mean the left and right bounds on the diagram that you've made. And then, you put in the mean and the standard deviation, which will generally be given to you in the problem. Then you just paste that thing to the home screen, hit enter, and you win. As a note, if your data doesn't have a left or a right bound, like if all you have is a right bound and it's everything above that, a left bound and everything above that, or a right bound and everything below that, you can just use very negative or very positive values, like negative 999 or positive 999. I just realized there shouldn't have been an S there. Oh well. We're going to go through two examples here, and actually they're going to be the exact same examples we did in the previous problem. In the previous problem, we set up the things, but then we didn't compute them. So to save time, we're just going to go back and compute the same things that we just did. So let's take a look at that. So we've got this question again about the mass of toys being manufactured having a mean of 400 grams and a standard deviation of 15 grams. You guys already have the curve from your previous notes showing that the mean of this distribution is 400, the standard deviation is 15, and we wanted to find the mass of toys that was between 395 and 415, right? So if you go on your calculator and but if you go bring up normal CDF on your calculator, it'll come up and ask you, okay, what is your lower bound? Well, for us, the lower bound is 395, right? Then it'll ask for your upper bound. Well, the upper bound of the region I want is 415. Then it'll ask for mu, which is your mean, and that's 400. It'll ask for the standard deviation, that's 15. If we punch all that stuff into the calculator, it'll come back and tell us that the proportion of that happening, or the probability of it happening, the proportion of data that falls into that range, is 0.472. So 47% of the toys that come off the manufacturing line have a mass between 395 and 415. These problems are incredibly easy if you know how to do it on the calculator. Okay, so we've got one more example. We'll take a look at that now. Okay, again, the number of minutes a child spends daily playing with a monster truck outside is normally distributed with a mean of 35 and a standard deviation of 7. Again, you guys already have, you're set up for this. You already have the picture. If you've got a calculator, pause the video, finish looking at the diagram, make sure you remember how to do it, make sure it makes sense, and then punch it in the calculator, see if you can get the right answer. So, representing a child playing for at least 45 minutes, that means there's a 45 here, and we're looking at the area larger than that. So, again, we go in and we put in normal CDF, right? We tell it that our lower bound is 45. Our upper bound, we weren't given an upper bound, so we can put, 999. Now, some people might object, like, wait a minute, this is a problem about a kid playing outside with a monster truck. Like, what kid is going to spend 999 minutes outside? True, good point, but your calculator doesn't know that this is about a kid outside. All your calculator knows is that this graph goes from negative infinity to positive infinity. And so we're just trying to pick a value that's incredibly large in the context of the problem so that it'll give us the right proportion. Okay, so we put that in. And the last things we need mu, which is 35, and we need our standard deviation, which is 7. If we punch all that in, the calculator comes back and tells me that this is 0.766. So, like 7.7%. And one of the things that's worth noticing here is that you can you have some sense of whether your answer is right just by looking at it, right? I mean, if this entire curve is supposed to be 100%, it makes sense that this would be a smallish number. In the previous problem, it was like, what, 47%? It's because we were shading like the giant tall part of the graph. When you get your answers for these things, take a second to make sure that the number that you're getting seems to have some semblance of like sense making in the whole thing. So in this one, you'll notice they were giving us data. They were giving us information about, it was 45 minutes. What is the probability? In the next video, we're looking at doing that in the other direction. So I'll see you there.